GMO Answers is committed to doing a better job answering your questions about GMOs. This year, we opened our doors to show how plant biotechnology works and how GMOs are researched, developed, and tested. Here are a few of the people and places highlighted in one of our first Open Doors tours.
We get to participate in some of the most challenging questions that essentially result in feeding the world. There's a huge growing population. Our ability to grow crops has to improve. Specifically, what I've been working on has been a fungal disease of soybean. It's a very, very costly disease in many parts of the world. Using pesticides to control it is really almost prohibitively expensive. So finding resistance to this disease is the most important aspect of this research.
The general approach is we are fundamentally asking the plant to tell us what genes are important and sufficient to give it drought tolerance. This is an example. 4 pots that are big and green, 4 pots that are dead and dried. So that is the type of result that we are looking for. And then we can go in and clone the gene and then identify what gene was giving us that drought tolerant phenotype. We've been searching for genes using Arabidopsis for years now, and finding one gene is not the solution or the finish line. You always want to continually find new genes that are better. Drought in particular limits agricultural productivity. There's estimates that it's tens of billions of dollars a year of lost productivity due to water limitation. And so we view that as one of the major ways that we can increase productivity on existing land to essentially feed the growing population that we're going to have to over the next 50 years.
So the primary function of our lab is to introduce these genes of interest into soybean and give back the same soybean plants now to our researchers so they can go back and look at the improved performance, whether it's insect resistance, disease tolerance, and so on. The first step that we grow soybean plants in the growth chambers. Once the plants are grown, we harvest the pods of soybean. We are multiplying these single cells of soybean. Normally each and every cell can grow back to a whole plant. It's got all the genetic information. We take the cells to the lab and we introduce our genes of interest, as I mentioned, whether it's insect tolerance or better oil. All the remaining steps are very similar to how a farmer does in the field. So a farmer, when he's growing soybean, he looks at the tissue of soybean, like for example leaves, and looks at the soil. That gives him an idea for next year how much of nitrogen or potassium he needs. So now these plants would probably have the trait that we have introduced, whether it's insect tolerance or nutrition profile, and then we take this to the growth chambers where it goes to the soil. From when we start till we get a product out is roughly about 15 years. And within that, 7 to 8 years is very much dedicated for the regulatory purpose. So that gives you an idea as to how stringent it is. You have United States, USDA, the APHIS, which makes sure the plants that we get out there, right, the transgenic plants, is safe to the environment. The second aspect is the EPA. They want to make sure that these plants are safe and whatever applications that they're doing in terms of growing the plants meets all the stringent requirements. The third aspect is the FDA, the Food and Drug Administration. So whenever it comes, for example, consumption of a particular product, so we need to make sure it's as safe as. So all of these, for example, we are very committed in terms of safety.